Welcome guys. So before I start, be sure to subscribe to my channel. Okay, so in this video, I may just quickly prove this inverse Fourier transform. So basically, f this capital F omega is the Fourier transform of this f of t. So basically, this is the one definition. So you just times this exponential minus j omega t. By the way, this j is just the imaginary unit. So you just times this exponential minus j omega t dt f of t, right? So since you already integrate out this t, so remaining will be a function of omega. Then the inverse Fourier transform basically just put this f of omega into this part, but change this minus sign to positive sign, and you integrate with the frequency. By the way, you need to divide by 2 pi. Okay, so we need to check that this will indeed give you back this small f of t. Okay, so just put this in. So we put this in, right? We put this f omega in, right? So and then we put this large omega as a definition here. Since we already used t, right? So now I use tau. Okay. Then I can exchange these. I can combine these two as this one, right? Exponential minus j omega tau minus t d omega, and I exchange the integrate, right? So basically, we first So in this equation, we first integrate. Oh, there's a missing d tau here, right? So in begin we integrate d tau and d omega, right? But now we change into first integrate d omega and the d tau, and f of tau is still here, right? So there's a formula that we already proved before. Basically, is this, right? Suppose you do this, then this will become 2 pi delta x. Okay. If there's a minus sign, there's a minus sign here, right? But the delta is basically the even function. So basically, even though this is plus or minus, then it does not give any difference. The equation is always 2 pi delta x, right? So this is 2 pi. So this is just 2 pi delta tau minus t, right? But you see that 2 pi cancel, right? So you get the f of tau delta tau minus t d tau, right? So when you integrate with tau, you just replace ignore this delta function and replace tau with t. So finally you get f of t. Okay, so that's the quick proof of this inverse Fourier transform and the inverse Fourier transform theorem. So basically, you start from f and you do the Fourier transform. You get large capital omega, and you do the inverse. Then you get back this f of t. Okay, that's it, and I will see you guys in other videos. Be sure to subscribe to my channel. Thanks.